Hi roboticist! Today we are going to deal with camera, and in particular what we're gonna do is to make a plugin for put a 3D camera in our environment, or better in our simulation environment. So the aim of this topic will be to put in our environment this 3D camera, which is an RGBD, which in particular has infrared sensor and also two stereo camera in order to perceive three dimension of the environment. So this camera is able to calculate also the distance where an object is related to the frame of this camera that we're gonna put in our environment. So, before to dive into it, make sure to subscribe to the channel for more topics like this. And let's get started right away. Before to jump in our environment and start to download the code and write the code actually, I think that it is important to show you the structure of how to plug any sensor in your environment. So the aim of this slide is to make you better understand what will be the pathway of your mindset that you need to have every time that you wanna to plug in any external sensors that come from other packages. So in particular, when you have to deal with a camera, an approach will be the following. So what you have is your package, the source file and the URDF file where you have the model of your robots. In our example, it will be a cobot.urdf file. And if you remember, in your URDF file you have to include all the xacro file and the model in order to simplify as much as possible the model of your robots. So in this URDF file will contain another xacro file that describe the camera, and in particular we are gonna have kinetic RGBD camera, and I suggested you to give more structure to put into another folder belonging to the URDF files and call it sensors. So in the sensors folder you're gonna have the camera urdf.xacro that describe the model of camera, and you will see that this xacro file will contain two important include file. So what we're gonna include is the gazebo.xacro file that will allows the ROS to interact with the gazebo environment, and it will contain all the gazebo plugin that we have seen in the last video, but the approach will be the same. And another important file that the xacro file of the camera will contain, that is also important to describe and model as best as we can the camera, will be the .dae file. And this file will contain all the low-level description of the camera, and this DAE file will contain the STL file and the PNG, where the STL file is the geometry it's a 3D drawing of the camera that we want to implement. And all this low level, let's say, file will be contained in the source folder. We are gonna create a meshes folder, sensors, camera, and then it will be contain all the file that describe our camera. So at reverse, if we wanted to go from the bottom to the upwards, we have this camera description, low level description of the camera, and that contains the STL file and the PNG. This DE file is contained or is included in our urdf.xacro file, and another file that contains this xacro file is the gazebo file, where there's gonna be the gazebo plugin for the camera, and on top of that there will be our robot description, in our case cobot.urdf file description, that will contain all these files. In particular, again, will be included the xacro file. The xacro file will contain the gazebo file and the DI file, and the DI file will contain the STL and PNG file. So I hope that you have a good understanding of the structure that you need to have in your mind, and also the pathway that you need to follow in your folder of your packages, in order to do not make any confusion and have a really structured pathway to deal with any kind of sensors that you want to put in your simulation environment. Okay, so let's start. And first of all, let's create the structure that we have talked about previously. So what we're gonna do is to navigate in our package. Let's see what we have inside, and what we can do is to go to our urdf file, urdf folder, sorry. So change directory urdf. Okay, and what we can do is to create another folder where we're gonna put our sensor that will be our urdf description, where we model our sensors. So let's make a folder and call it sensors. Okay, then if you remember, we needed to create a new folder inside our cobot simulation package. So let's come back. So let's create another directory and call it meshes. Okay, navigate in the meshes folder. Of course we don't have nothing, and let's create another directory, call it sensors, action sensors, navigate through it, and let's create another folder, call it a camera. So basically the structure will be that in this sensors folder what we're gonna do is to put not only the camera, but you can put whatever sensor you want. So it can be infrared sensor and any kind of optical sensors, switches, whatever you want to put in your environment. So let's create another folder and call it camera. Okay, navigate into it. Approach for modeling our camera and put in our environment will be from bottom to the top. So we are gonna start with the DAE file. We're gonna download STL and the PNG file, and we're gonna go upwards in our hierarchy, let's say, of our package. So let's create the DAE file, and we're gonna call it kinetic rgbd camera and DAE. Okay, so here what we can do is to navigate into my directory. I'm gonna put the link in the description down below, and you just copy and paste. It will be much better, and we can discuss it later on. Here we go. We have just copy and paste, and you just don't need to do anything. Just copy and paste. This will be the description of the low-level description of our camera. That will be our kinetic one. And then in this folder you need to copy and paste the file STL and PNG. So let's do it. Okay, so let's rename, and in order to give a standard name here, let's name it kinetic.gazebo. Okay, it's done. So now what we can do is to create our kinetic.gazebo file. So what we need to do is to navigate into our urdf folder and sensor folder, and we are going to create a file, the xacro file for our kinetic RGBD camera. So let's call it kinetic RGBD camera .urdf.xacro file. Okay, so then just copy and paste, and we are going to navigate through it. Okay, so first of all, I remember you that you will need to change the name of your package. In my case will be cobot_simulation, and here you can see that we are including right away the kinetic rgbd.gazebo.xacro. So there will be something here that will be related to the file that we need to create. But before to create, let's just go through this code and see what there's inside. So here there are some dummy inertia properties of our kinetics, because otherwise we will not be able to spawn the camera in our environment in Gazebo. And then here what we need to do is to create a macro. So the macro will be called kinetic.rdf, and we need to pass name and parent, and of course we are gonna use this macro in our cobot.urdf file. So again, then you need to put to create some link for this camera. You need the inertia value, the geometry, and here you can see that the geometry of your camera you're gonna take from your kinetic.stl. Again, here remember to put your package cobot simulation, so mesh sensors, so kinetic STL will be here, and we're gonna take out from here. And again, let's do the same for the low description file for our kinetic camera. So now you can see that this file has been taken from our sensor camera folder. So again, here let's since that I'm gonna call it camera, let's call it camera again. So here you can see in particular case I need to make some changement because I'm working in another package for creating this video, but you can just download, copy and paste from the repository that for which I will provide the link. So then you're gonna have the joint and a lot of joint for the RGB, depth optical joint, and so on and so forth. Okay, so let's save and let's create another file where there will be our Gazebo plugin. So here I'm going to create in our URDF sensors. I'm gonna create another file, and I'm gonna call it kinetic.gazebo .xacro. Let's make sure that Gazebo, okay, it's the same, and then just copy and paste. So here we go. Basically this file is containing this huge macro that we're gonna call it kinetic rgbd camera underscore gazebo, which the only parameter that we need to put would be the name. And then you will have this degree to radiant parameter that we're going to put in our cobot.urdf file. And basically here you can see that we are going to create the topic for our camera, the depth topic, the image row, and the points clouds, but we are going to see each one later on in RVs. Okay, and so what it's important to point out is that we are going to include this plugin, which relies on these libraries, the libgazebo, ROS, OpenE, kinetic.so. Okay, so as a recap, we have created our camera.da file that relies on this other file, the camera STL and the camera PNG. Then we have created in our sensors folder, contained in the URDF folder as well, the camera urdf.xacro file that contains the gazebo.xacro file and the DA file as well. So then what is left is to update our cobot.urdf file that include the camera kinetics urdf.xacro file. So let's do it right away. So I would suggest you to create another file, and let's call it cobot_camera.urdf in order to do not make any confusion. So this will be, first of all, I just copy and paste this. Okay, and now what we need to do is to include our kinetic RGB urdf.xacro file. So what we need to do is to include it right away. So let's put some constants. This is useful to convert the degree to radians, and you need to put this constant, and this scale will be useful later on, and this is the pi number. And so before the gazebo plugin for our ROS control, we need to define our RGBD sensors in our URDF file. So this will be the usage of our macro that we have created in our xacro file. Let's check if we have call it kinetic._rgbd. Yes, it is. And you can see that you need to pass the name and the parent. In fact, there will be, we are gonna call it RGBD camera and base, and basically that's it. So here what I put here is the position where our camera will be in our environment, and here the orientation. So what I forgot to tell you is that here in our urdf.xacro file we have used the gazebo.xacro, where basically we have used that macro, giving that macro the name that we will put in our urdf file. So let's check if we have called it kinetic rgbd camera gazebo here. Kinetic rgb camera underscore gazebo. Okay, so it seems that we have everything, and what is left is to try out with the launch file. So what we could do is to create another file, another launch file that will be very similar to one that we have created before. So let's call it spawn underscore robots underscore with camera. So we have the cube and the camera in our environment. Launch file. So basically it will be the same, with the exception that we need to update our urdf file, that in this case it will be our cobot underscore camera urdf. Okay, it should be everything. So we could try. So let's build the package first of all by typing catkin make. Okay, and then let's spawn it. So ROS launch cobot simulation, and then our launch file. Let's see if everything is working. Okay, if we press play, it doesn't fall down due to our ROS control, and you can see here there will be our camera. And as you can see, it has the same model that we have seen on internet. Here you go. This is here. And you could change the position and the orientation of your camera by modifying the number that you can see here. So basically, if you change this number and this you will change the position and the orientation. So, what is important to check is the topic that this camera and the Gazebo plugin has created automatically. So, let's run another terminal and type ROS topic list. And now you can see the magic that the Gazebo plugin makes. So here you can see all the topic that has been automatically generated. It is important to see what the camera actually see, and due to the position I think that is gonna see the gripper of the robot itself. So just let's check it. So what we can do is to run with the ROS run another package embedded in the ROS package version that you have installed, and this is going to be rqt underscore image view. Tap for auto compilation. Here you go. This is another GUI, let's say, like the one that we have here, the rqt reconfigure, and here what we can do is to change the topic. So for example, if you want to see with the namespace rgbd camera the depth image ROS, then the image will be this. If you want to see the infrared, it will be like this. And for example, if you want to see an RGBD message here. Okay, this is something that our camera actually see. And what you can do is to see in RVs. So I'm gonna show you how to do that. So let's open another terminal and just run RVs. Okay, here is opening, and then as a fixed frame you can select our RGBD camera depth frame, and then let's add by topic point cloud 2 topic belonging to the RGBD camera namespace, and here you go. You can see here another kind of visualization with RVs. Okay, that's all for today. I hope that you enjoyed this video. Most important thing here, and the key takeaway here, is that now you should be able to plug any type of sensor and camera in your environment. And this will be very useful when we go deeply in robotic application like pick and place, where we're gonna use a depth camera like the Kinetic one for sensing the environment, check the distance between the gripper and the object, and finally pick and place whatever you want. I'm looking forward to see you in the next video, and as always, keep learning robotics with ROS.